Hi, my name is Steve Kinney, and this is a course on React performance. Over the last few years, React has undergone some significant changes that have taken previously difficult to solve performance issues and made them solvable in just a few lines of code. In this course, we'll cover the tried and true practices of co-locating state to prevent unnecessary re-renders. We'll also dig deep into understanding how React Fiber works under the hood. We'll explore the React compiler. Finally, we'll look at powerful new abstractions like React's new support for optimistic updates. With everything you learn in this course, you'll be able to build professional-grade React applications with confidence.
I want to introduce maybe two very broad, very hand-wavy categorizations for performance issues in your application, right? Because they are both equally as problematic, but very different in their nature, right? And so kind of giving us a distinction early on, I think, is super important. One is the big thing that is slowing down your application, like that one bottleneck. You open up those Chrome developer tools and you see it, right? You feel it in the app. You know where it is. You're probably even thinking of a place in your app right now where you know that if it is not presently there, it is slowly growing and emerging. And these are interesting because on one hand, they are very noticeable, clear and present danger, right? On the other hand, it is remove the thorn out of your side and it is gone, right? And that's both terrifying and also somewhat relieving to know that you can just figure out how to solve that one issue. And that is going to be a thing that we definitely focus on today. I would argue that some of the concepts towards the end of the workshop, right, are very focused on that. You have this one specific pain point. And these are some of the ones where I would say in something like React 16 or 15 or what have you, it was kind of terra incognita about how one would even solve that. You might have to kind of hit the escape hatch, grab a ref, and maybe go back to vanilla JavaScripting it for a second. But now, some of the biggest, gnarliest problems of 3 years ago, 2 years ago, will be shockingly simple to fix, right? Sometimes it'll only involve a few lines of code, where a few years ago it would involve possibly a month of your life you'd never get back. The interesting part with some of these techniques with the new features in React 18 and 19, like transitions and React Fiber and stuff along those lines, is it is very easy to, if especially you've been doing React for a long time, that they might have just kind of snuck in there and you didn't even know that these magic wands that make large problems go away are just there and you can actually solve them with 5 lines of code. Or things like optimistic updates, which are not easy. If you're still doing stuff all right, I'm gonna set state with an error state and a loading state. Those will be Booleans. I'm gonna flip those on and off. And then when the promise resolves, I'm gonna flip this one. And if it catches, there are easier ways, right? And it's very easy if you've been doing it for years to be this is the way I've always done it. I heard those APIs exist. I don't really know what they are. This is the way I do it. Let's take some time. We'll explore them. And you'll be wow, that was worth it. Because that's how I felt, so I'm projecting. So we've got the big ones and the big gnarly things. And then there's the more insidious kind of performance problems, which is the slow accumulation of little things that begin to slow everything down. And on one hand, no one of these is particularly this is a unique problem I've never seen before. It is a series of death by 1,000 cuts, right? And these are the interesting ones because there is a lot of literature out there written by people who I can tell from their job descriptions are talking about writing code a lot more than they're doing it, right? And there are things well, only optimize if you have a problem, which is true. Over-optimization is bad and premature, and you're not getting anything done because you're designing the perfect system is bad. But also, it's we all know that sometimes prevention is the best medicine because let's say it's 1,000 of these small things and it's going to be, we know every step of the refactor, but it's gonna take a month. We know how easy that is to get signed off by leadership or product managers or stuff along those lines, where it is easier said than done, right? And so figuring out what the things are early and often, so both we, when we write our code, And then also when we're code reviewing each other's code and kind of see the things early on to prevent the accumulation as we go through. So they're very different kinds of problems. Like the big one is clear and present and you need to deal with it because like the whole thing doesn't load. This is ones where it's like, I go to a given UI for a place I used to work and like the page took, I measured it, 2 minutes to load, right? And I knew enough about what was going on to know exactly how it got there and exactly how impossible it was going to be unwind. These are both legitimate dangers and like things that we can, at least somewhat prevent, right? Like there will always be the like a whole bunch of things like come together in the like perfect way and you're like, despite everyone's best intention, right? We ended up here, that happens. There'll be some things that maybe you can't fix. Right? It's like, oh, if we had a better API where we didn't have to make 10 API calls to get the complete user model, and everyone agrees that we should definitely get that better API, and it's been 4 years. Those are all things, and then how do we navigate that and how do we deal with that? Those are all unique things that despite a blog post on a thing, right, happen no matter what. But let's, like look at some of the initial ones here. Now the obvious, and again, some of these are contrived because like making purposely bad apps is a lot harder than you think it is. Typing into this input field probably should not re-render like almost everything, right? Does anyone, just looking at the flashes at the very least, have a hypothesis to what the issue is? You haven't seen the code. I'm not expecting you to know, but I'm opening the floor for hypotheses. Yep. Nate.
It's updating a context or global state.
Let's go with the second one because I didn't put the context API in this one just yet. We can we'll solve some problems and we'll recreate some problems. Right now, it is effectively the first and foremost, easiest, slam dunk, you can almost never go wrong with rule is the balance of pushing state down, as you're keeping state as like low as you can, as high as you need it, as low as you can get away with, right? So if I jump over to this code, you will see like the first cardinal sin. You're like, I would never do this. Let's go into deep thoughts. I would never do this, right? Yeah, you would never do it in the application component. You've done it somewhere. I know that you've done it. Even if like it had a good reason at the time and then things changed and it just ended up in that state. Like most of the worst parts of my code base were the code when it was written was good and everything else changed around it, right? So let's not get into shaming here. Things happen. Which is, if we look at the application component, we can see that we have this draft thought, which is that thought that we're going to create and add to the DOM, right? In the application component. We got a lot of problems in this, obviously, because it's an intentionally bad app. And then we take that draft thought and the ability set it, and we pass it down into this capture thought. And one of the kind of interesting like conundrums that there's not necessarily a right answer to, which is like this function now gets called, it goes to its children, right? And like that's down into capture thought, which then could like call something back up. There are two options, which is to push everything, all the state down, or to flatten that component tree, right? Sometimes it's not about like pushing the state down and memoizing stuff. It's just like, did that need to then render another component? Or could that have just been inlined in the component? Like the answers are, maybe it would be more performant to inline it, but you're using that component 6 other places, at which point it doesn't matter what's more performant because you need to maintain this code. And like, honestly, the cost is not that high. Like no one saw this thing lagging as I was typing. It was just flashing a lot. Like live with it because the ability to maintain this code base and have it be reliable and consistent for almost no other than a fake app problem is not that bad, right? But if then I'm also like, you can assume the capture thought is maybe a one-timer, right? But if it was like button, well, you're probably using that button lots of places, right? And there's, if it's just some CSS classes, maybe you do it like that. But maybe your button, it's also like one of those buttons that they pass it in href. It can also be a link. bane of all of our existence, but every designer makes us do it. Those things, there could be logic. It makes sense to pay that cost. Don't over-optimize that, right? This is a fictitious example. But we pass in draft thought so that I can put it in that input field. And then we pass in set draft thought so we can update that state. And then we pass in this on submit. Honestly, other than the act of adding that new thought into the array of thoughts, which has to happen up here because the thought list and the individual thoughts need it, the act of keeping that draft state and changing that draft state doesn't need to live up here. Push it down, right? Because the render tree only goes down unless it's been given calling stuff back up to the application. So in the world's simplest refactor, which just felt right, they'll get harder, don't worry. But it felt polite to start us off with an easy one. We're going to take this logic that only is of a concern to the create thought, and we're going to put it where it belongs, right? And so we'll see some red squigglies for a second, but we'll take this, we'll cut out that hook completely, right? All we really need to do to go back up is to get to that array, right? And obviously now TypeScript's angry at me, but we'll save that for a second. I'm sure Veet's now angry with me too. We'll get rid of the on change and the draft thought, because now we're not passing them in anymore. We only care when they hit the submit. And I'll show you another hack you could do a little bit later. We need to pull in use state. And then on change, we'll just set that draft thought. And I see no red squigglies, and I see no red squigglies, so I should be good. My font is very large, so if you see something I'm missing, see something, say something, right? And hopefully, what we'll see, I'm gonna give it a page refresh so I don't have a false positive, is the entire application is not re-rendering from, honestly, just a sensible refactor. Let's say you omitted something from that array. Now, if React compiler's whole job is to look at your code at runtime and find these optimizations, guess what else can do that? ESLint, right? So I have ESLint rules that would give me a squiggly line, partially because I'm also live coding in front of people and wasn't willing to take the risk on a different topic later. But theoretically, couldn't we do the same thing, right? And that is what React compiler seeks to do. And the cool thing about React compiler, now I've warned you, technically a release candidate, also used in production for Instagram.com, and I'm sure a ton of other places. Opt-in. Also, you do not need to be on React 19 to use it. Yes, it is new. It is also built on top of the primitives from Fiber. So everything that uses Fiber, I think that's 17 and later from memory, are also fair game. So you can use it today. However, it assumes that you are doing everything by the quote unquote rules of React, which there are probably parts of your code base that you're not. So the mature thing to do, and I've got a little guide in the thing, is a incremental approach, right? Do not, or pay the consequence. I don't know. Do whatever you want. But what it seeks to do is analyze your code at runtime, kind of like ESLint does, and figure out where these things would have normally gone and do them for you, right? Hence why I'm not spending too much of our precious time together perseverating on this, because ideally you should know how it works, you should have an understanding, but also hopefully it is like it is in stuff like Svelte and Solid abstracted to the compiler. And maybe unless you can't find a weird edge case or you have some other strange thing going on, hopefully I aspire to be something you don't worry about all the time. To kind of see it in action and get a nice understanding of how it works, there is this playground.react.dev. I'm going to turn off these tools for a second. This is obviously a somewhat silly example, but you can see that this is effectively what React compiler will do to any of your code, right? And let's start with the default one that they put in here, because why not? On one hand, in this case, you could argue it is slightly more code, but not really. So the first one is you have this we're importing this C, letter C, from React compiler, in this case, runtime, right? Obviously, if you're using the Babel plugin, it's slightly different. And what it does is, and you don't have to write any of this code. You're like, I don't understand what this is, and it makes my brain hurt. Good, you don't write it. You just write React, making believe you didn't know that use memo, use callback, React memo exists. This happens behind the scene. Think about it like those lanes with the bitwise operators that stressed you out. If stuff guess what? It's all electrons going through a copper wire at the end of the day, and a bunch of ones and zeros. It's very stressful the lower down the stack you go. But what we do here is we say, like, hey, with this C, we're gonna say we need effectively an array of one thing, right? Which we'll store in here. This is effectively an array. And we're gonna say if the first thing in that array is this like sentinel, because there's nothing really going on in this, right? Give us back the component, cache it, right? And then never even run this again, right? Because it's putting as the first thing on the array. The next time it runs around, the first thing on the array is this like literal thing that doesn't change. Then go ahead and return it, and we're done here. Now if we give it like, let's say we'll call this greeting, and we'll say that it takes a name, and we will then okay, slightly more complicated. Effectively, though, it has not changed too much. You'll notice, though, there's none of these like arrays, none of these like functions. We are using much cheaper abstractions here, which is we make a 2-element array right here. Too much. We make a 2-element array. Right? We go ahead and we begin to say, hey, is the first thing in that array equal to the string name? Right? If it's not equal to it. Okay, if so, we go and we run the child function. So this is effectively React memo, right? Just a much simpler version. And we save it to this TO and we put it in the array. So for the name we pass in, the first thing in the array, the JSX that would have come out is the second thing in the array, right? So if the name is not the same, go run the child component, the new name, the new return value. If it was the same, the return value is just the second thing in the array, and we're done. So it effectively is using React memo, but even a cheaper, simpler version, because it's not calling a function and comparing this object with that object. It is saying, like, I literally stored a reference. I will update the reference. If they are the same, I'm always going to do the right thing. Mechanically similar to React.memo, without instantiating new functions, calling a bunch of stuff. It is just doing very clean value checks effectively, incredibly simply.